Hello and welcome. In this problem, an electric car weighing 6,000 pounds accelerates from 0 to 75 in 7 seconds. We have to find the electric energy consumed in million joules, given that the car has an energetic efficiency, that is the battery electrical charge to kinetic energy efficiency is 75%. So if simply the electricity consumed will be change in kinetic energy divided by the efficiency, which is 0.75. So it's quite a simple problem. The second part is the cost of the electricity. So if we know how much electricity is consumed in any unit, you can convert that to kilowatt hour, the standard unit for electrical consumption, and then we can figure out the price, because 1 kilowatt hour is given, it costs 10 cents. So we'll solve the problem using the DeskCal, one of the simplest TESTapps. To launch it, we click on TESTapps and then click on DeskCal. And there are some examples. To see videos of the example, click here. To see the codes generated, click here, readable codes. And then we are going to generate now the code for solving this problem. So we start by clicking in the input area. Whenever you click calculate or enter key as calculate, calculated values are displayed in the bottom half of the screen. The comment line begins with hashtag. So first thing we'll write is the given values. And what are given? Mass in pounds, lbs. Mass in pounds given is 6,000. Note how we always put the unit. Velocity at state 2 in mile per hour is 75. We could write velocity at 1 as in mile per hour. It's kind of to generalize the problem, is 0 in this case. So likewise, the other given values I've just listed here. Efficiency is 0.75 and price of electricity cent per kilowatt hour is 10. Notice how we always add the unit at the end of the variable name. Okay, so the first thing first, now we convert to SI units. Okay, so mass in kg will be mass in lbs times how much is 1 pound is how many kg. To figure that out, you don't have to really leave the app. Notice on the right hand corner there is unit converter. We can go there and we can search for, say, kg, or just say mass. We're looking for mass units. So 1 kg is so many 2.2 pounds. 1 pound is 0. Notice how easy it is to switch the units here. But you can also go and select the unit from your list here, left list and right list. The left one is from unit, the right one is to units. Pretty intuitive. So we could put 6,000 right here to get how many kilograms, but instead we'll pick up the value 0.454. So 0.454. If you want, you can write a comment that using the unit converter. So we can calculate. So mass in kg has been found. So similarly, the velocity can be converted, and I have already done that here. I've done exactly the same thing, gone to the unit converter page and typed in mile per hour, and velocity came, and then basically meter per second this is the default units. The bottom half has the English units or units similar to English units, and the top half has SI units. This is how they're organized. So 1 meter per second is so many mile per hour. So 1 mile per hour is so many meter per second. So therefore 75 times this will be our velocity. 2 times 0.447 is our velocity in meter per second. So now let's start the analysis. Let's call up this block energy analysis. Just to simplify, we'll just say KE1 in kilojoule equals 0. Ideally, we should say velocity 1 meter per KE2 kilojoule is what? Mass in kg, velocity of 2 in meter per second, square of that divided by 2000. Why 2000? We know half mv square, but the factor 1000 comes because the unit in SI, kilojoule. So therefore, delta KE in kilojoule is KE2 minus control C, control V. So this is my, so when I calculate, delta KE has been found. So delta KE, so therefore electricity consumed in kilojoule must be change in kinetic energy divided by the efficiency of the electrical vehicle. A million joule, it will be kilojoule divided by 1000. So we found the answer to part A. If you want, you can write a little comment. Part A. For part B, again, we know electricity consumed in million joules. We can go, or kilojoules, we can go and find using the unit converter what is the conversion factor for electricity from million joules to kilowatt hour. And basically a kilowatt hour is 3600 kilojoules. You can intuitively understand that. A kilowatt going for 1 hour is 1 kilowatt hour, the standard unit of electricity. So a kilowatt means what? Kilojoule per second times 1 hour, 3600. So that's why the unit is 3600 kilojoules in 1 kilowatt hour. So we divide the kilojoule, energy consumed in kilojoules, by 3600 to get how many kilowatt hour is used. Of course, we could go to the unit converter and type in, say, kilowatt hour or say energy, and then you can see 1 kilojoule in kilowatt hour should be somewhere in the top. Yep, somewhere there. So as we just deduced, 1 kilowatt hour is 3600 kilojoule. So now we have found the answer for part B also. The cost of electricity turns out to be at 10 cents a kilowatt hour is only 2 cents. No, sorry, not 2 cents. Electricity consumed cost is 5.6 cents for this car to accelerate from 0 to 75 miles per hour.